In this video we're continuing with quadratics, and today we're going to solve quadratic inequalities, and this is video lesson 1 of 2. Now we already have experience of solving linear inequalities, so we're just taking this a step further now and looking at the quadratic inequalities. Now, like linear inequalities, we know that there are 4 inequality symbols. We've got less than, greater than, and less than or equal to, greater than or equal to. So that's the same for our quadratics here. We can come in these 4 forms. So the quadratic greater than 0, greater than or equal to 0, less than 0, or less than or equal to 0. And in order to solve a quadratic inequality, we need to determine which part of the graph lies above or below the x-axis. So obviously when it's greater than 0 or greater than or equal to 0, that's where it lies above the x-axis. And obviously when it's less than 0 or less than or equal to 0, that's where it lies below the x-axis. And we can determine this via a sketch of the parabola. So we have 2 forms of the parabola we should be familiar with. One with a minimum turning point, that's where we've got the general form of our quadratic equation and the a value is greater than 0. So our coefficient of our x squared term is positive, that gives us a minimum turning point. And if the coefficient of the x squared term a is negative, we have a maximum turning point. And if we just look at what happens with our inequalities within this. So this section here tells us that ax squared plus bx plus c is less than 0. And if it's greater than 0, we are looking at these areas here. When we have a maximum turning point, when our inequality is greater than 0, we are looking would almost appear to be inside the parabola. If you like, you're almost looking at the area enclosed by the curve and the x-axis, if you like, and you're looking at these boundaries then. And if it's less than 0, sorry, that's the greater than 0 one, and if it's less than 0, it's these areas that we are looking at. So, we'll have a look at an example. We want to solve x minus 3, x plus 5 greater than or equal to 0. So you can see that in this example this has already been factorised for us. So if we are looking to solve this in the first instance to try and get our roots, because remember we want to try and sketch this so that we can examine the graph. So our roots from this bracket would give us x equals 3, so one of the roots will be 3, 0, and from this bracket x would be negative 5, so our other root is negative 5, 0. That allows us to sketch our parabola. It has a minimum turning point because our x squared term will be positive. We'll have a positive coefficient, in this case 1. So we've sketched our parabola, and we want to know where will this parabola be greater than or equal to 0. So that is these areas here, that's where it's greater than or equal to 0. And we need to look specifically at the x values where that occurs. Remember, we have an inequality involving x, so where does that happen? And that's in these places. So we can see that x can be equal to negative 5, or it can be less than negative 5. So it can be any of these values here, all the way to negative infinity. It can also be equal to 3, or it can be greater than 3, all the way to positive infinity. So our answer then, our solution to this inequality, is that x is less than or equal to negative 5, or greater than or equal to 3. Now, just now would be a good time to pause the video and make sure that you take the graph down as well. That's really important here. Now, I should have said before you pause the video to take that down as a note. if we had been asked to solve for x minus 3, x plus 5 less than or equal to 0, we would have had this area in here, okay? And that means that x would have to lie between negative 5 and 3. So it would be these values that we would have been examining. So just trying to show you the difference between how we would write the two sets of inequalities given your original expression being greater than or equal to 0 or less than or equal to 0. Now example 2 then, we want to solve x squared minus 4 minus 21 less than 0. Now you can probably see this time that it's not been factorised yet, so we need to go about that. So you can use your grid method or whatever other method you've been shown, and we will get x minus 7, x plus 3 less than 0. Now if we try and find the roots here from this bracket, we will have x is 7, and from this bracket x is negative 3. So our roots are 7 and negative 3. You can see that the coefficient of our x squared term is positive, so therefore we have a minimum turning point. Now we want to know where is this graph, where is it less than 0? And that encompasses this area here. And the x values which will give us this area are lying here. So where I've put this black line, they're lying between negative 3 and 7. So x lies between negative 3 and 7. And that's our final answer. And like I did with example 1, what if we'd been asked to solve x squared minus 4x minus 21 greater than 0? Well, that would then encompass values less than negative 3 or greater than 7. So you can see again the difference in the inequality there. And example 3, folks. Solve 4 minus 9x squared less than 0. Now hopefully you've noticed this time for our factorising that we have a difference of 2 squares. So we have 2 minus 3x, 2 plus 3x less than 0. And if we get our roots from here, solving here will give us x equals 2/3 and negative 2/3 from this one. Now, this time our coefficient of our x squared term is negative, so we actually have a maximum turning point this time. And we can see our two roots here, negative 2/3 and positive 2/3. And we want to know where is this less than 0. So that encompasses these areas here where it's less than 0. And we can see that that would be values less than negative 2/3 and or greater than 2/3. Okay, so x is less than negative 2/3 or x is greater than positive 2/3. And like I've done with the other examples, if we'd been asked to solve the opposite 4 minus 9x squared greater than 0, we would actually be encompassing these values in here. So x would lie between negative 2/3 and positive 2/3. Okay, so just now would be a good time to pause the video and take these down in your notes.